Here, I'm going to go, Emily, with your permission, I want to stick with unskewed binomials. I'm going to keep probability at 1/2. So this is Max and his Crocs. Some examples would be flipping a coin and guessing on heads or tails. Pulling a card, betting on red or black, like a roulette wheel-ish. Roulette wheel's kind of unfair, actually. Genders, male or female. Great discussion came up in the last class with the gender question. The concern was, this is wrong. This isn't 50-50. And I said, yeah, I've seen that study too. I've seen that study too. And I don't think it's statistically significant. No. I think there should be more than this. There should be more than male and female. I'm like, oh, that's a very good point. And it reminds me of that student who emailed me about the chickens. Remember that? There's a 1 in 10,000 chance that a chicken has both male and female organs. So what I did was, for you guys, I made the distribution up for that. Said, okay. What I did was, I took that information and made it trinomial. So I said, okay, let's assume that this 1 in 10,000 exists, yeah? So 1 in 10,000 birds that are born have both male and female parts. So, number of roosters, number of chickens, number of the third case, I call it other, trinomial. Trinomial, yeah? So roosters, chickens, and whatever the third classification is called. These are all the possible arrangements of 4 birds across those 3 categories. You can have no roosters, no chickens, and 4 of the others. You can have no roosters, 1 chicken, and 3 of the others. No roosters, 2 chickens, 2. No 3 and 1. 0, 4, and 0. 1, 0, 3. And this is all the cases. That's all the possible arrangements of the 3 types of sexes of the birds. Now what I did over here was I kept track. There's the 1 in 10,000 that the student told me the rate was of the other. There are the probabilities adjusted now for the 1 in 10,000. Remember how it used to be 90% for a chicken? Now it's 0.89995. That's you take 1/2 of that 1 in 10,000 away, and then the 10% rooster becomes just under 10%, 0.09995. And I said, hell yeah, let's see what the differences are. So I recalculated the binomial as a trinomial, which is wicked fun. And this is kind of the stuff we'll do in 244. Where we use a bag of M&Ms though versus chickens. M&Ms have 6 colors, milk chocolate M&Ms have 6 colors, and Mars always claims they have these percentages. We test that. We have to crack bags open, count the colors, and we test it. It's hexanomial. 6 colors, hexanomial. We also test an iPod for randomness. That's decanomial, because I put 10 songs on the iPod, we check this iPod for 10 songs. So you can apply the binomial out to as many categories as you need, make it multinomial. Here's the trinomial. Now, what I found when I calculated the probabilities in this column, look at any situation that contains one of the other genders, any situation that contains one of the other genders, look at the probabilities that have it. What do you notice about them?
They're so small.
I love the word teeny and small. Yes, they're extraordinarily small. Hopefully that makes sense.
It's like irrelevant almost to the
I'm not saying the situation of a third gender is irrelevant. I'm saying statistically it is though. Because here's the deal. You see these 5 numbers right here? They should look familiar to you because those are the ones we calculated in class. Those are the binomial probabilities. 65.61%, 29.16%. Look at how close they are to when you account for the case with the third gender. Here's the error in the percentage. There's the oh, you can't see that. The overriding error is off to the side there. Let me shrink it down a little bit. There. If you don't account for that third gender, you're only off in 0.04% overall. That makes it statistically insignificant to talk about. Statistically! I'm not saying you don't talk about that gender. I find that very, very important. But as far as analyzing the likelihoods, I'm saying you can ignore that. There's no reason to talk about it because it's not affecting the overriding outcome all that much. If you sample more birds, I think there's a much bigger chance that it will affect it. But for 4 birds out of a course of hundreds of thousands of birds, it's meaningless statistically. Does that make sense? I wanted to share that with you guys because it was a great point that came up and I promised you guys I would do that. Actually, A, I remembered to do it, yay. B, I'd forgotten that I had done it, so thank God one of the students said something. But you don't find this interesting, that's okay.
Yeah, but is it different with humans?
I don't know. Well, it's the same argument. It's just I don't know what the rate of it is. I don't know the 1 in 10,000 in humans. Mathematically, you could do it the same way.
Yeah.
I don't know what the rate is, and I asked the students to supply me the rate, so we'll hear back and we'll see if I get the rate from them. Maybe you can give it to me instead. Okay? Find me the rate of that. If you can find it. The student did the same thing and had no luck. So we can rerun the numbers at break, Natasha. Happily. Cool? So I want to share that with you guys. Just because I think about this stuff probably way too much than I probably should. Alright, so back to here. Natasha's question is, can we apply that logic to humans? I don't know. Let's find out. Let's find out. So, what I want to do though is go back to 50-50. We can adjust these if need be once we have the third case. This is what the distribution would look like if you flip the coin 3 times. You've got about a 12.5% chance of getting no heads, 12.5% chance of getting 3 heads, and about a 3/8 chance of getting the other 2. This can be gotten using dist fill if you chose to use dist fill. If you chose to use dist fill, you could get this exact same curve. You would plug in smallest x is 0, largest x is 3, binomial, probability 0.5. This is the distribution it would give you. This would be if I watched Max put his shoes on 3 times instead of 10. Okay? If I watched him put his shoes on 5 times, it would look like that. If I watched him put his shoes on 10 times, which I did actually, it would look like that. Now, remember how many times he got his shoes correct? Once out of 10. That's over here. What's the chance of that happening? Pretty small. Less than 2% it looks like, yeah? Around 1%. So since there's only a 1% chance of it happening, did we think he was guessing? If he was guessing, he would have landed closer to the middle of this. He landed too far to the side. So we didn't think he was guessing. We think that he actually thought that was correct. Alright? But let's keep watching him now. If I want to be sure, I better keep watching him. There's 25. There's 50. What are you beginning to notice about these beautiful curves? They're beginning to become bell curves. Which means as these values head off towards infinity, i.e. become harder and harder to count, the curve that we call the binomial starts to look like the other curve we've been talking about all term, which is this wonderful bell curve. And the best part is it doesn't stop there. Check this out. Here are 100 randomly selected American women's heights from ages 18 to 24. Now that is nowhere near as gorgeous a bell curve as this, but do you agree that it is bellish? Yes, within a margin of error, which we'll discuss next week. Yeah, what would you call the average height of an American woman between 18 and 24? What would you call an average height of a woman? If you had to give one number to it, what would you call the average?
65 inches.
65 inches? I think so too, Carol. That appears to be the middle of the curve, yeah? Looks like you got a tail out here. Then it goes down. This is a little too high maybe, but that's just sampling error. What would you call the standard deviation of this curve? If you had to give it a standard deviation, what would you call a standard deviation? How many inches would the standard deviation around that average be? What do you think? What do you think?
2.
Vote for 2. How come? How come, Rory?
I just looked appropriate.
Oh, good! Well, define appropriate. I'm curious. Define appropriate, if you don't mind.
I don't know. I really don't know. I can't find it right now.
That's okay. No, don't be sorry. Don't be sorry. I'm going to draw it out of you guys. When we talked about standard deviation on bell curves before, how did we use it in context? Corbin, go!
Oh, it's 2.
It looks like the majority of the information is within 4 or 12.
Good! So, if you I'm going to take my hands and I'm going to open them up until you guys think we've captured about 95% of the data. Okay, ready? Don't want to stop. Stop? Okay. This goes from 61 point, call it 62. This is about 68. 62 to 68 is how far? That's 6, yeah? So cut that in half. That's 3. That means 2 standard deviations down is 3. 2 standard deviations up is 3. That means 1 standard deviation is 1.5 inches. That's not too damn close to your gut feeling, Rory, of 2, isn't it? Does that make sense? You see what we just did? The range of values, you guys told me to stop here, yeah? 62 to 68 is 6 inches. That means 3 inches down, 3 inches up. Mu plus 2 sigma is 3. If the average is 65, and this is 68, it's a difference of 3. That's 2 of those little sigmas, 1.5. Let's do it again. Let's do it again. Different data. If you didn't like that, let's use different data. Let's use LDL ratings on guys. Huh? LDL ratings on guys. Give me the average.
What's LDL?
Say that again.
What's LDL?
Oh, what is LDL?
Lowest real life.
Which kind?
Bad.
Bad. that low density lipid cholesterol. This is that accumulated crap that you get in your, yeah, you don't want this. You want HDL, high density lipids, you want that. That's the fish oil cholesterol, that's good stuff. Vegetarians have a hard time with that. So, but LDL is the bad stuff. This is the cheeseburger cholesterol. And I had to talk to a friend, she's like, yeah, I don't eat peanut butter, there's too much cholesterol in it. Do you eat animal peanuts? She's like, no. I'm like, well, then I don't understand how peanut butter has cholesterol in it. Well, because it's full of fat. I'm like, okay, time out. Let's have a little nutrition lesson, of which I know very little. I know you can't get cholesterol. You get a lot of fat in peanut butter, but you can't get any cholesterol. Anyway, average LDL level. Give me a number.
5.
Carolyn says 5. Are we in agreement with that?
Yeah.
I am too. I am too. 5. Okay. Standard deviation. Vote for a half.
Yeah, me too.
Vote for a half. Let's do it. Here we go. 95%.
Yeah.
Stop.
Yeah.
So we got from like here to here. Let's go out to here if you don't mind. That's 3.5. That's 6.5. How far is that? 3.5 to 6.5 is 3. Yes. 3, which means this is 1.5. That's 1.5. Cut that in half. 0.75. Yes. Damn close to 0.5. So 0.75, 0.5. There's your standard deviation there. Getting the hang of this? You've done it before, of course. You've done this before. Hey, we just did a whole bunch of math. Was that a bell curve? Is that a bell curve?
Sort of.
Arguably. Good. Sort of. Yes, I like the sort of. Arguably it is. How about this one? Let's do one more and then take our 5. Bell curve?
Yes.
IQ. What is IQ?
Intelligence
Dumb
quotient.
test.
Intelligence quotient. A dumb test.
The test how dumb you are.
Test how dumb you are.
Yeah.
Go more with that. I've never heard this before.
The IQ test, you had to test above a certain range. If you're below whatever it was, you're mentally retarded.
Well, let's come back to that.
It's to test how.
Let's come back to that because I
there's
think
no way to
careful.
test intelligence.
there's intelligence and there's stupidity. I'm not sure that they are complementary of
But
each other.
there's no real test intelligence because there's
So what the hell is this?
this how unintelligent.
Okay, let's leave that alone. What is IQ? I'm not saying what, I don't care what intelligence is, because I agree with Austin, I can't measure it. What is IQ?
It's like your rating on the measure of like everybody else's, how they.
And how do you get your measure?
Relative to their scores.
Relative to who?
The average.
The average.
What's it called again? IQ is intelligence.
Quotient.
What's being quotiented?
The amount of people.
What does quotient mean? What does quotient mean mathematically?
Divided.
Divided by. What's being divided?
And 20.
Mental age over your actual age. That is what IQ is by definition. You take a test, it gives you your mental age. Dumb maybe, but your mental age. It gives you your mental age. You know your chronological age. Both of which are continuous variables, yes? You then divide those two, multiply it by 100, and that's your IQ. That's why the average IQ appears to be 100, because that means you are as old as you are intelligent. This is also explains why very young children kind of go off the chart IQ-wise. Suppose you got a 4-year-old kid, wicked precocious 4-year-old kid, I can't think of any of those, that take an IQ test, don't you dare do this to your kid, and they test as a 6-year-old. What is that kid's IQ? 150. 6 divided by 4 is 1.5. He's off the chart, IQ-wise. Is that valid? I have no idea if it's valid or not. Depends on what you mean, what you want to do with the IQ test result, right? That's what IQ is. I'm not going to pretend to understand what it actually implies. We'll get that slippery slope. But that's what IQ actually is. It's your mental age, whatever that's defined as, divided by your chronological age. That's what's being quotiented in your IQ. The average is 100. What's standard deviation? What's standard deviation? Ish. All of it? Well, I don't know how to interpret that.
65 to 125 maybe?
Oh, so you're saying, you're giving me 95%.
Yeah.
Oh, good. So Rory's going like this. He's going, so like this, right? So you're saying it's 70 to 120.
Yeah.
So what is that? What's,
It needs to go out one more to the right.
Yeah, it would go.
like to here?
Yeah.
Okay, so 70 to 130. What is that? That's 60. So that means 30 down, 30 up.
So 15.
And that's exactly what it is. By definition, an IQ test has a standard deviation of 15. Nice job, guys. You just tracked it perfectly.
15 years?
15 points,
Oh,
IQ
my
points.
God.
No, The years cancel, if you will.
Okay.
Since you're dividing mental by chronological years, the years cancel off. These are IQ percentage points. What do they mean? Hell if I know. I don't even pretend to know, but I know how it's measured, which means we can chit-chat about it. You guys ever call? Well, we'll come back to that. We're 5 minutes over our break time now. Take your 5, let's come back to this. I want to come back and pose a question about IQ, which ties us into our next topic.